According to an airline, flights on a certain route are on time 80% of the time. Now, suppose 20 flights are randomly selected and the number of on-time flights is recorded. The first part is just going over why this is a binomial experiment. And so if I scan through the options here, I definitely want to include A because the probability of success is the same for each trial. So for each of these 20 trials, the probability of a flight being on time, a success, is always 0.8 or 80%. So that's true. B is not true. Don't want to include that. But C, this has to be something in a binomial experiment that the experiment is performed a fixed number of times. That's like the opposite of what D is saying. D is saying it just kind of like goes on forever until you get what you want. We don't want that. The trials are independent of each other. And for each trial, there's only two options that are completely separate. You can have a success or a failure. Those are the four things we want. So I'll check my answer. That was correct. Anyway, what is the probability that exactly 14 of these 20 flights are on time? Okay, to use technology to get this, in class we talked about how you could do it by hand, but there's a calculator in StatCrunch. So you can click on where it says question help, go down to StatCrunch, and there's no data, but it does open StatCrunch for us, and we can use a calculator to figure this out. Go to Stat, Calculators, and we're going to select binomial because we're talking about a binomial experiment. So here's the calculator, and what we would like to do is input the information from this problem and this part of the question into here. For starters, n is the number of trials. Here we're told it's 20, so I'm going to put 20 for n. Second, the probability P is going to be for a success, and here we're talking about an on-time flight, so that's going to be 0.8. So I'll put 0.80 for our 80%. And lastly, down here, this is where we're going to use this 14. To say exactly 14 means I don't want a less than or equal to or greater than. I want only equals. So this is like saying the probability that your random variable is exactly, and I'll put the number 14. When you click compute, it puts the corresponding probability over here. And if we round this to 4 decimal places, that is 0.109. Okay, that 0 is going to get rounded up to a 1. So 0.1091. All right. You can think about if like this makes sense. I mean, that seems pretty reasonable to me. Part B goes on here to say, now interpret this probability. In 100 trials of this experiment of selecting 20 flights, about how many of these experiments will result in exactly 14 flights being on time? This is a matter of taking 100 and multiplying it to this probability, which will move the decimal point 2 places. And if we round to the nearest whole number, it's going to be 11. So, you can do this in your head, or you can just use another calculator. Take this probability, multiply it by 100, and then round as needed. So I'll check my answer. Okay. So the rest of this question can be done by using the binomial calculator in StatCrunch, but let's try this one too. So the probability that fewer than 14 flights are on time. So I'm going to go back to StatCrunch and look at my calculator. Okay, now we're saying fewer than 14. So that's not exactly, that's going to be less than. So this to me says the random variable is less than 14. And this is the corresponding probability for it. Again, rounding to 4 decimal places, we get 0.0867. So the language within the question tells you, is it less than, greater than, less than or equal to, greater than or equal to. So that was 0.0867. Again, interpreting this data, taking 100 and multiplying it over here, we'll move the decimal point 2 places. So it's going to round up to 9. So we're talking, roughly, approximately this many. And yeah, let's see, the probability that at least 14 flights. So this to me says 14 or more. So if we go back to StatCrunch, all I'm going to do is change this from a less than to a greater than or equal to. And again, here it gives us the probability that we could round and place in our answer here. You can also use this between if you're asked to go between two values, but that is everything that you'll need to complete this question.